Oh, what to do now here? I think O's help, we have to take it. We should calculate there the resultant potential. No, that's all. There, nothing is there. What is the potential at point P? So initial energy plus Ki equal to UF plus Kf. What is initial interaction potential? M naught into potential at point P plus M naught into VE square by 2. Finally, it should go to infinity. So let's assume that at infinity, let it come to rest. If it gives some any kinetic energy at infinity, substitute that kinetic energy here and solve for V. It's left to you. At infinity, let it most of the problems will make it to rest. If at infinity also, if it is having some kinetic energy, that kinetic energy you are going to substitute here. But this has to be zero because there's no interaction. How to calculate that potential at point P? There's a more generalized way of learning. A potential, this point P lies outside the solid sphere. This lies outside the solid sphere. So what is the formula? Minus G2m by 3r whole square. The point P that a distance 3r from the center of the sphere. Then what is the potential due to this?
Where should not be then?
What happened? No?
Where should not be there, sir?
So square. Huh? Okay, I'm talking about field only. Okay, fine. A potential due to the disk. I think if you don't know potential due to this formula, no way you can do anything, you know. Is it okay? No? So some data is a very must. So unless we don't remember the data, it's not possible. So especially this gravitation chapter, no, we must know all the data. Corresponding data must be there for everyone. So if you can remember data, you can manage, otherwise gone. So minus, so I think we brought in terms of sigma, if you can remember. I'll write the formula. It is equal to minus 2 pi g sigma root of x is how much? 3r by r square plus 3r whole square. So what is sigma? Sigma, let me write it separately here. Sigma is what? M by pi r square. So this will become minus 2gm by 3r. Sigma is m by pi r square. 3r, here root 10r will come. R root 10. So this on simplification, one pi get eliminated. So 2gm of course, root 10 will be greater than 3. Will end up in negative. So this, I need not to put negative sign. The sign will come from where? From the calculations. I think you have to be careful. This small mistake usually students will do. Potential due to any body should be negative only. For a disk, what happened? The sign will come by the calculations. That value you have to substitute, that you will get the escape velocity. These are the troublesome questions for you in exam. So this formula, if you don't know this, then finish over. You can't derive this in exam. I'm making things clear. You can't derive. You can't derive. Nobody can derive in exam. That much of time will not be there. Okay, substituting this here. Let me m by pi r square. So this will become m naught potential. There's everything we have to introduce here. So 2gm solving for V will get the required answer. So now escape velocity, don't think that something, it can be for any system. And now you have to ask one very good question. So why you are not taking interaction potential between the particle and the disk, and between the sphere and the disk? You see that we didn't took, no? So shall we say something like a binding energy? So you should supply kinetic energy which is equal to binding energy of the system. What is the binding energy? The energy with which particle is binded to the sphere and the disk. I think that is what this energy. There's interaction potential between the disk and the sphere. Even if you want to substitute that, and it will come also here, even particle when goes to infinity open, these two will be here only, separated by distance 6r. So that will cancel out. So therefore we are not showing it. But actually you have to show that also. But if they're both in LHS, RHS, it'll get cancelled out. So therefore we just made a practice of just only showing the interaction energy of the particle with the objects here. Because see, we have discussed only without the disk, no, only with respect to sphere. Now if you, there's interaction between the sphere and the disk also there, that will come here. Actually you're supposed to write. Then what meant that in UF also will come, will get eliminated. So what is this quantity now? What name we should give for this? Shall I say binding energy? Now, this is something very important because as we go for some IR problems, no, this idea will help us again. So you should supply kinetic energy equal to the energy with which the particle is binded to the system. So therefore, what is the binding energy? Of course, it will be negative, no? It will be binded with this one, this one. So what is this? What I should call the energy with which the particle is binded to the system. So if you supply kinetic energy equal to binding energy, okay, then what will happen? It will escape. Binding energy will be negative because it's binded, no? So put that negative, then solve for it, you'll get V is some positive value. So therefore now what is very important now? When particle is escaping, if it wants to escape, no? So then what happen? What is the binding energy? We should take that one. We should not go for total interaction potential of system. What is UI? UI is not total interaction potential of system. Only the interaction energy of the particle with the system. So there'll be more confusion. So therefore we'll better say binding energy. You can bring it between any two, this one. So you should supply kinetic energy equal to binding energy of the system. So this quantity separately we'll call it. Okay, this is about the overall the condition like this, energy of satellite, all this particular thing. I think we have only 7 minutes time. Huh? Okay, let's, some time is, so I'll give some, if they give some potential, suppose say in a region, if you know potential, so potential they'll give like this, alpha x, beta y. How to calculate the field? So to get the x component of field, I'll differentiate. Just math-based problem, somewhere will help you. So I'll differentiate with respect to x. So how much it will be? Minus alpha. If I differentiate with respect to y, it will be dv by dy. So this will become how much? Minus 2 beta y. Then what is the total field? Is given by ex bar so minus alpha I cap minus 2 beta y j cap. So if they give potential, no, if you differentiate with respect to x the function, you will get x component of field. If you differentiate with respect to y, you get the y component of field. Suppose if in a given region, if the potential is given by the formula x square yz, then differentiate with respect to what to do with yz. Keep it as it is, no problem. So now this will become yz into 2x. What is ey? Ey will be minus of dv by dy. So this should be equal to how much? X square z. What about z component will become minus x square y. So then what is the total field? Ex bar plus ey bar ez bar. So this should become 2x yz I cap z cap x square y k cap. Anywhere numericals may come, so they'll help you a lot. If you know potential, how to get field, to get the x, y, z components, differentiate relative with respect to x, y, z. If you know potential, how to get the field, already I shown one integration method. So later in the because all these are math-based problem, which may not be very important in gravitation. On Friday, I'll discuss few. If they give potential, how to calculate the field. If they give field, how to calculate the potential. So don't touch these things in books. Even if you find more, no, leave it on Friday. Focus on now on the satellite, the conservation of mechanical energy related problems.